Okay, welcome pre-calculus students to lesson 4-7. There's a few things you're going to want to have out before you watch the rest of this video. So after I give you these things, you might want to pause and get out your things and make sure that you have everything you need. You're going to need to have your textbook open to lesson 4-7, page 291. You're going to want your notes out, and then you're going to want to have your graphing calculator, but you need to make sure that you go and you change that mode right now to degree mode. Everything that we're going to be doing today needs to be in degree mode. So it looks like I'm okay. You need to be okay too, so that we can get answers that make sense today. Okay, so go ahead and pause me and make sure you get those things out, and then unpause me so you can watch the rest of this. All right, for starters, here on this first page, we have the issue of non-right triangles. We have oblique triangles, which can look a lot of different ways, and it doesn't matter what it looks like, but it's not going to have any 90-degree angles whatsoever. You're going to have one that's bigger than 90, maybe a couple of small ones. It looks like it's leaning over to the left, or it's got a skinny part in the middle. It doesn't matter. The thing that you need to pay attention to with these types of triangles is getting the sides and the angles to match. And if you can see here in both of these drawings we have here, if this is angle A up here, then across from it is side A. And if here's angle B, there's side B, angle C, side C. And what I also want you to notice is that the angles are capitalized, but that the sides are lowercase. And that's a way to distinguish between whether we're talking about an angle or whether we're talking about a side. So sides are capitalized, angles are capitalized, and sides are lowercase. If you can draw the triangle that's being talked about in the text, you can draw it and get those sides and the angles corresponding to each other. I think that'll be a big help to you. If you try to draw them first and see that side A corresponds with angle A, then it'll be harder to get confused. You can still confuse yourself. You're still able to do that, but it'll be a lot harder to do that. So set that triangle up, draw that thing for yourself if you're a visual learner. If they just give you the dimensions of things in the book, they say side A is 2 and side B is whatever, then try to draw it first before you go on beyond that. We're going to have two laws today that we're going to talk about, the laws of sines and laws of cosines. And each one of those different laws has conditions that fit that particular rule. There's only certain parts within the rule for you to use. So my suggestion is, with any of these triangles, the first thing you want to do is look at that triangle and see what things you're given, and set it up so you can see what the condition is for that. If you remember from geometry and even last year in trigonometry, if we can identify if it's angle, angle, sine, which is basically you can figure out the third angle, so it's angle, 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 side, but two angles and a side, angle, side, angle, side, small side, angle, side, side, angle, side, 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 or side, angle, side, then you've got all the information you need to figure out all the other parts of that triangle, even if it's not a 90-degree angle. Okay, for non-90-degree angle triangles, these are the conditions that you're looking for. And if it's these first ones here, these first four, then you're going to be using the law of sines. Side, 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 and side, angle, side, law of cosines. If you need to, go ahead and pause me right now and write down that little chart in your notes. Okay, now you know that there's an asterisk there by that one, the side-side angle. This is called the ambiguous case. Nobody likes to hear about that. They don't want anything to be ambiguous. Ambiguous means we don't know how many answers there are. For all the other conditions, you know what all the sides and what all the angles have to be. But for side-side angle, there may be no solution, like number 11. Okay, write that down. Number 11, no solution. There might be one solution. If that's the case, we have a 90-degree triangle, or two solutions, and we'll be looking at those along the way. My advice to you is that you first identify the condition that you're dealing with the triangle, and then just look and apply the corresponding law to the set of situation that you've got. Here on this third page here, then, we got the same setup, okay? We got this triangle here, and if we make sure that we label A goes with A, B with B, and C with C, then we're ready to go with the whole situation. You got A, B, C, capitalized angles, A, B, C, lowercase are the sides. Okay? Get those all right, and then you can move on from there. Sometimes they'll give you the picture, and sometimes they won't. Okay, I want you to look at these two triangles here, triangle 1 and triangle 2, and I want you to look at them for just a minute, pause, and then I want you to consider what conditions that you have for these and then what rule that you would use. So take a look at triangle 1, look at all the sides and all the angles, look at triangle 2, look at the sides and the angles, and write down on your paper what you think the condition is and the law that applies. So go ahead and pause me now. Okay, welcome back. So you look at triangle 1 there, okay? Triangle 1. What are we dealing with? Triangle PQR, let's call it. Well, we're given Q, we're given angle P, and we're given side Q. So we have a side, or I'm sorry, we have a side angle situation, or angle side. And from the previous page, we saw that that means that we're supposed to use the law of sines. So you can give yourself a high five if you got that one right. The second one, triangle DEF, look at the conditions there. The conditions are side, angle, side. It's side F, angle D, and side E. So that one means that we would have to use the law of cosines. Okay, so you're going to have to do this for every triangle that they give you. You're going to want to identify what are the angles, what are the sides that I get, what's the conditions that I'm working with, and then you go from there. All right, I paused myself there for a moment so I can get a snack. Page 5 here. Click. There we go. Page 5. You look at these two triangles here, and this is where it gets a little tricky. You see on the left, you got side, little side angle condition. Side, little side. If you're following along in the book, we're looking at the ambiguous cases, either one or no solution. Page 293, 294, 295. What we have to watch out for is that little side. Little side's fine. No problem with the little side. And here it's got the 4.5. It's the smallest of the three. We know we're going to get one answer. The problem is when it's not that case. Right? If it's the little side over here, we're going to use the law of sines. If it's over here and we don't have the shortest one in between the other parts, then we could have multiple answers here. Here in my situation, I'm going to try to keep this leg about 9.16, and I'm going to sweep it around this way. And you can see that I can make a triangle like right there. That would be one possible triangle, but then the other possible triangle would be something out here. And those are two totally different types of triangles. If this is your triangle, then you've got a fairly big angle up here that goes along with a big side. But if this is your triangle over here, then you've got a pretty small angle up the top and a pretty small side at the bottom. Since we don't know what the smallest side is, that's the ambiguous case where there are actually two sets of answers. This side stays the same, this angle stays the same, but this angle here and this angle here are going to be different, and this side and this side are going to be two sets of answers, and you're going to have to list them both. Okay, you can look at the book for an example of that and how you find out what those two angles are. So either a big angle B or a big side B and a small angle B and a small side B. Those things go together. So you're probably going to want to see page 293, that key concept at the top of the page, and pause, copy that thing down into your notes before we go on. That has every possible situation that you got there for ambiguity to know what you need to do. Okay, let me give you some things to look at here with those laws. What are those laws? Well, out of the book, here's what they look like. The first one here, all the sides are on the top, the angles are on the bottom, but they correspond. A goes with A, B goes with B, C goes with C. These bottom ones here are called just the reciprocal form. And it doesn't matter which one you use, they're the same. The only reason you might use one instead of the other is that, let's say that you want to solve for a side. You're going to want to choose the rule where a side is at on the top, so that your unknown is in the numerator. Otherwise, you're going to have to move too many parts around. You might get a little confused. If you're going to solve for an angle, you might want to use this one down here. And with this rule, law of sines, you're only going to use two of those three parts to make a ratio. Ratios have four parts. In this case, you have three things that you do know and one thing that you don't know. You might be A over sine A equals B over sine B. You might have A over sine A equals C over sine C. It doesn't matter. You're only going to use two of the parts, so you have three things you know and one thing that you don't know. Okay, I'm going to give you an example here. I'm going to go to number 12. And we're going to look to see if we have two sides and the corresponding angles, the side angle condition, or if we have two angles and a side, which really means you have all three. You got angle, side, or angle, side, angle. So in number 12, it doesn't draw a picture for us, but it does give us some information for us to work out the problem. We've got angle A, we got side A, and side B. And then your job is to find everything else. You're supposed to find side C. You're supposed to find the other two angles. Okay. So your first job is to go ahead and find angle B, because all the other parts are there for you to use these four pieces of the formula. And so if you do that, here's what your equation will look like. And what I want you to do right now is to solve that equation for angle B. Okay, you're gonna move the parts around, do some inverses stuff, but solve that and then pause, and then I'll give you the answer here in a minute once you unpause me. Okay, scroll down and here's what that should look like. And if you didn't get that, you need to practice that. Okay, you need to practice that. So there's the setup. And what you do is you go ahead and you go in here and you change, you just plug in the numbers, okay? So B was 12, and angle A was 27. Say, okay, that's 27, and side A was 18, okay? And to solve that, you're going to go over here and I'll go ahead and say, what would that be? And you should get an answer that's about 17.6. That should be what you get for that problem. Okay, once you've got that, then you go after those other answers by taking different pieces of that thing. If you've got two angles, now you've got three angles. And if you got three angles, you can use anything that you want to, any of the formulas you want to solve for the other missing parts. Okay, if you need help with a worked out version that goes all the way to the end, you're going to want to look at like example 6 in your book. The law of cosines applies to side angle side and side side side. If you're working with side angle side, the formula looks like this: a squared equals b squared plus c squared minus 2bc times the cosine of a. And if you're given b, c, and a, angle a, then you can solve for side a by taking the square root of both sides. Now, if you're working with side side side, you have to move a lot of the pieces around because you're going to be solving for the angle a. And eventually that formula is going to look like this. So you might want to write that down. Pause me, write that down, because you're probably not going to want to derive that every single time you have to solve for an angle, given side angle side or side side side. Now maybe you're curious where this whole a squared equals b squared plus c squared, all that stuff comes from, because I know that you guys are curious people. So it actually comes from working with the area of a triangle. And you remember this from algebra, where you're given a triangle, but you didn't have a right angle, so you had to construct a height. You had to construct a height by adding a perpendicular line into a triangle ABC, and then you had to figure out what that height was. The trick of these is to go ahead and define height in terms of the things that you already know. And you go over here to the angle C, and you say, okay, well, I know that the sine of C is going to be h over a, the height compared to the hypotenuse of that triangle. Okay, then you rearrange the parts and solve for h like this. H would equal a times the sine of C, And then you go back to the original formula here and you replace that h with a sine c, and you get this thing down here. And so you notice you got that b a sine of c thing that you have in those formulas, a b sine of c. And this formula right down here is an area formula that you can use for the side angle side condition. You can find the whole explanation for that in the textbook, page 297 in your textbook. You've got side A, you've got angle C, and you've got side B. You've got side, angle, side. And so you can solve that triangle given just those parts. You don't need to be able to figure out the height. It's able to be derived by using the parts that you do have. And that's the moral of the story there. The other formula is back page before that, where it's called Heron's formula, and this applies to side, side, side. If you're given all three sides, then this is our magic little formula here. And S is a magic number that you have to figure out. S stands for the semi-perimeter. And you can see here you're taking half of A, B, and C. It's half of the perimeter. Okay, so that's where the S comes from, semi-perimeter. And once you've figured out what S is, then you can go in and just toss that number in here to this formula, and out comes the area of a side, side, side triangle. Now this works with every triangle that you're given all three sides. It works with right triangles, it works with oblique triangles, and that's what's so awesome about this formula. So here's an example. If you got an ABC triangle, and I used a Pythagorean triplet here to make this easy. ABC, 3, 4, 5 triangle. You solve for S first. Okay, so you look at that and you're like, three sides are 3, 4, and 5. That adds up to 12. 12 times 1/2 is 6. So we just go in here and we're going to change those S's to 6. So 6 times 6 minus 3, 6 minus 4, 6 minus 5. 6 times 3 times 2 times 1. Okay, that's 6 times 6. That's 36. And the square root of 36 is 6. And you think about that, what would that have been if we just had gone 1/2 base times height with a right triangle? 1/2 base of 3, height of 4, hypotenuse of 5. That still would have been 6. 1/2 3 times 4 would still be 6. You can get your answer using either method with a right triangle, but you can get that answer for any oblique triangle using Heron's formula. Give a high five to Heron. Sing a song for him. Do a dance, because he's awesome. Came out with this beautiful formula for the area of any side, side, side triangle. So here's what you got to do. 1 through 5, odd. 11 to 23, odd. Oh, you can read. So there you go. And that's all for now. Hope you had a great day, a great basketball game, and do your homework, hug your mom.